your focus, you have to sharpen your mind, basically do a lot of questions, right? So then you are going to like move ahead. Okay, so basically you can, okay, super clear, right? So you have to be very cautious in the class, you have to be very focused in the class, and next thing is that you should never miss a class. You should never miss a class, because in class 12th as well, the Vikram batch which I am teaching also, like Vikram and Homi also I am teaching in physics. So the Vikram batch students, I have seen that many students, they, when they come to the class, they say, sir, like in the comment section, in the chat section, they write that, sir, I'm not able to understand this thing, I'm not able to understand that thing. Then I just ask them, did you attend my previous class? Then they say, no, sir, I couldn't attend the last lecture. There was some, my niece came in my home, I couldn't study, I went to play, I was scrolling reels on Instagram, so things like this. So if you are doing like this, then that means you are not serious at all. Whether there is some niece or whether there is something other, so everything, all these things, these are just excuses. So one thing I want to say is that E, I think I told you this in the live class as well, that E stands for effort. E stands for efforts and not excuses. And not excuses. So if you are giving any excuse that I didn't come to class for such and such reason, those are just useless excuses. So you have to put efforts, you don't have to make any type of excuses. So first and foremost thing is that you should come to the class. And if you don't come to the class, then you should watch that recording of the previous class which you have left. Okay. And about notes, yeah. So there's one question about notes. So all the notes, all the things which I'm going to write, it's your like choice whether you want to write it down or not, because all these notes, they are going to be made available to you in PDF format. All these things which I'm going to write, for example, today's lecture is going to be made available to you, right? So all these things, they are going to be made available. But if my writing is not legible, if you like feel like my writing is not good, like that good, okay, I know that my writing is not that good, then you can try to make your notes in your own manner. Like you can look into the lecture, and after that you can make notes after the class. Or otherwise, if you don't want to make it, then all these PDFs will be provided to you, so you can study from those as well. But it's my, like, in my personal opinion, I'll say, if you can see my handwriting, like if it is good enough to study, like if you can see it properly, then you have to just look into the content. You don't have to look into the writing. So just, you need not to make any notes. You have to just, everything will be provided, so it will not waste much of your time. Okay. But yeah, you can make some short notes for some formulas and all, which you try to, like, which you sometimes forget, which you forget after some exam, or like in your past experiences, if you give NEST or IAT, some things which you forgot. So all those important formulas you have to write down. Okay. So how many questions you should do in a day? I'll say in a day you can do around, if you can do 100 questions in a day, then it will be very good. 100 is a lot. Let's say if 100, each question, if it takes around 3 minutes to solve, then 100 into 3 is 300 minutes. 300 minutes divided by 60. 6 5s are 30. So it will be 5 hours of self study of only solving questions. I'm saying only solving questions, no theory at all. So if you have studied all the theory, and after that you are going to solve some questions, you should be solving at least 100 questions. Like, aim for 100. 100 is a very big mark. It is a top notch mark. So you should be aiming for that. Otherwise, like, you can do like at least 20 to 30 for physics. Okay, similarly 20 for 30 for mathematics. For chemistry you can do a little bit more, 40 for chemistry, and again 40 for bio. So how much? 40 40 80. So it's gonna 80 plus 60. It became a little too higher. So if I want to make it a little bit less, but at least, yeah, at least 20 question of mathematics, 20 question of physics must be there. In fact, I'll say 25. So 25 mathematics, 25 physics, these are total 50. And then you can go for 30 for chemistry and 20 for bio. So this is going to make it a total of 100. But those 100 questions should be good. They should not be very easy questions, right? They should be at least moderate to hard to very hard level of questions. Okay. So yes, you can ask if you don't understand any word on the board. You can definitely ask in the chat. I'm like, even while teaching in the class, I'm looking at the chat a little bit. So we'll be looking into that as well. Okay. Okay. Yeah. So my name. So my name is Kalit Gautam. So it is KALITGAUTAM. I think many of you students must be from South India. In South India, you say Gautam as Gautam, Gautham. My surname is not having H, it is just having T. Okay. So my name is Kalit Gautam, and I did my bachelor's and master's in physics from IISER Bhopal. So basically, I appeared for IISER aptitude test in 2017, and I give JEE Main plus Advanced in 2016. And in 2016, I was at NIT Hamirpur in mechanical engineering. After that, I left mechanical engineering for physics, and I went to do physics at IISER Bhopal. Okay. So, Saima Areen, 100 just for physics? No, 100 not just for physics. If you do 100 just for physics, it will be just way too much. You have to do at least 20 to 30 for physics. And it's going to take a lot of time because you have to study theory as well. You have to revise as well. Meanwhile, you have to do questions. But yeah, if you can do 100 questions just for physics, then it's going to be definitely amazing. You are going to secure like easily, you will be securing top ranks like AR 1 to 10 easily. Because if the more questions you solve, the better understanding you are going to have. Okay. So yeah. And now next thing, reference book, yeah, I'll tell. Wait. So next thing I want to tell you the ways to study. So how you need to study. Way of studying. So how you have to study. So today's class is not going to only about speaking of some wise knowledge and all. This is the last slide I'm going to make, and after that we are going to continue our studies. Okay. So let's say, because this is important as well. Because if you committed some mistake in the past, then those mistakes should be rectified. Just wait a second. Is there a vector class after basic mathematics? In basic mathematics, I'm going to teach vectors as well. So you need not to worry about anything. Everything which you are going to have issues with in physics will be taught in basic mathematics. Okay. So yeah, wait. So your chat is visible. Yeah. So the first thing which I'm going to tell you is that first of all, you have to study the notes. First of all, you have to study the notes or the books. So you have to study these things. First of all, whatever you are taught in the class, whether my notes or whether the reference books which I am going to make you refer to, you have to study those things. Okay. So like after the class, if I teach you something today, so you have to study it. And after studying it, second thing is practice. Second thing is the most important thing I'll say, practice a lot of questions, a lot I mean, actually, practice a lot of questions because this is going to make you stand against others. Practice a lot of questions, okay. So second thing is practice a lot of questions. And while practicing these lot of questions, you need not to do like you have to solve every question in under 3 minutes or 2 minutes or so. No, there should be no time bound. You can do these questions like even if you take 10 minutes to 15 minutes in one question as well, you have to just solve it wholeheartedly without looking at the solution. So let's say if you are given some question, let's say if this is a block of mass m and I am applying a force of F on it and the coefficient of friction is given mu, after what time it is going to attain an acceleration of 2 meter per second square. Let's say if you are going to given a question like this. If you are not able to approach this question, then just try to mingle around with that question. If you are not able to like get any idea, then just go out of your room or your home and just take a little walk in the park, drink some water, drink some milk. Okay? Don't drink cold drinks and all those things. They are going to increase your sugar and caffeine intake, so that's gonna like spoil your brain basically. So it's better if you drink some milk or maybe water. That's the best thing for you. In fact, honey. So you can take those things, and after taking those things, you can come back to your study table and you can start with this question again, and then you'll get some new ideas, some insights to get to tackle with this question. So the thing which I want to say is that in practice a lot of questions, you have to do questions wholeheartedly without giving up. Basically, you don't have to give up, right? So basically, not giving up. So I'll say never give up. Basically, never give up. So you never have to give up in front of questions. Even if it is a very hard question, just give at least half an hour on it. If you give half an hour on it, then that half an hour is going to make your brain grow. It is going to make your neuron circuits. You know about neurons. So you know neurons are like this. So like the endings of neurons. You know about this synapses. Do you know about synapses? Can you write down in chat? Do you know about synapses? The more you study, the more you put a lot of time in a question, these synapses are going to come closer, right? These synapses are going to come closer. Okay. So when these synapses are going to come closer, the electrical impulses in between them is going to be faster. So faster is the electric impulse, the faster your brain is going to work, right? Just like some older laptop. If some older laptops, they are having Intel i3 processor. Nowadays we are having i11th generation, I think 13th generation or maybe 15th generation processor is going to come. So what is this generation? These generations of processors, they are having more cores, more threads, so they are having more processing speed. Initially, like some laptops are having 1.8 gigahertz. Some laptops in this era are having 3.1 gigahertz, and some are having 5.3 gigahertz, like so much of processing power. So the more you put some time in a question in a good manner without giving up, your synapses are going to come closer. The closer the synapses come, the more the transfer of electric impulses is going to be faster, and the better is your brain processing speed is going to be. And the faster is your brain processing speed, there is more chances of selection, right? Okay, so it is fine to take longer time to solve question. Yes, it is fine to take longer time to solve questions, but initially it should be like the case for 1.5 months. After that, slowly your speed should grow. Initially, let's say it is taking quite some time to solve questions. After that, this time should decrease, and ideally this time should come nearly close to like 4 to 5 minutes. And if it is very close to 3 minutes, then it is very good. Like in mathematics or physics, if it is close to 3 to 4 minutes, it is very good. For chemistry, it should be definitely like under 3 minutes, and for biology, it should be under 1 minute or so, like whatever. So the more calculative or brainiac subject is mathematics or physics, this is going to take time to solve questions like 3 to 4 minutes. Otherwise, it should not take that much time, right? Okay. So this is my second thing, which is not giving up. And after that, after practicing, what you have to do is revision. What you have to do is revision. So what about revision? In my personal opinion, you should be revising all the things, whatever the things you are taught in this class. Let's say today, whatever I'm going to teach today is Tuesday, right? So from Tuesday, Wednesday, Thursday, Friday, Saturday, for 5 days, whatever I'm going to teach you, you should be revising all those things totally as a whole in Sunday. Okay, so revision every Sunday. So every Sunday you should revise all the things which you are being taught for the past week. And also before going to sleep, like today, let's say if you are going to sleep at 10 p.m. or 11 or 12, whatever time you are going, 12 a.m., whatever the time you are going to sleep, just before going to sleep, look at all the slides of all the subjects. This is the way to revise. Just look at it, have a look at it, just close your eyes and just try to recapture it. Okay, this was the thing which we were taught in the class, sir taught us this, we have to look into this. So just try to recapture it, all those things. So this is the way you revise. Okay, so and this is the revision every day which you have to do. Every day before sleeping, you have to revise the things which you are being taught in that day, and about that particular week or that particular month, you have to revise every Sunday. Because if you don't revise, then you're going to forget everything, like a lot of things on the time of exam. Because during the time of exam, you are having this much amount of syllabus, very huge, massive amount of syllabus. So that much amount of syllabus, you have to keep all those formulas in your mind, right? So, and after that, okay, so there is one question. How do revision for questions we have solved? Okay, how to do revision for questions? So listen, the questions which you have already solved, you don't have to revise those questions. When you are doing revision, you have to revise the formulas, the concepts, and even before going for formulas and concepts, you should first do the questions which you have marked. So while solving the questions, mark some questions as star. Mark some questions as star. Those start questions will be the questions where you're having some problems, which are having some tough concepts, or which are having a lot of intermixed concepts. So those are the questions which you have to solve during revision. Or maybe in revision you can take some other material, like from some online materials or some books. You can refer some books as well, and from those books you can try to solve new questions. So this is the way you revise. And while during the revision, if you are having some problem with some question, let's say with fourth question you are having some problem, then just go on your class notes, on your PDFs, these notes and all, and just go and look at those things. Okay, what is the thing which I am missing right now? What is the thing which I am forgetting? Then go and write that thing in your short notes, that yeah, this is the thing which I am forgetting. So this is how you revise, right? Okay, which book I recommend for physics? So the book I recommend for physics, I'll write it over here, wait. So after that, so this is revision, and after revision, I'll say the last thing, which is mock test. The last thing, which is also very important. All these 4 points are very important. I know that like the previous class which you had yesterday was of biology, I guess. So biology sir must have already told you all these things, but this is from my side as well. Okay, so the next thing is mock tests. So what about mock tests? At least say I'll say weekly or maybe in 10 days. Okay, weekly or maybe in 10 days, you should give at least one mock, and this should be timed. Okay, timed mean you have to do it in under 3 hours. Just like in actual exam conditions, you have to lock your room. Don't let your parents, don't let your siblings, don't let your niece, your grandma, whatever, whoever, or maybe if you're having some pet dog or cat, don't let anyone come in. Just lock your room and just do this timed mock test for 3 hours. And in this mock test, you are going to learn how you are going to manage time, how you are going to give time distribution to physics, mathematics, chemistry, biology. So this time distribution you are going to see, and you are going to learn how you are going to solve questions in such time frame. So this is why mock tests are very important, because ultimately those mock tests, they are going to prepare you for the real exam, right? Okay, so where can you get 100 questions every day? So 100 questions, like you'll be getting some DPPs from our side, so I'll guess you'll be getting 80 questions from overall in physics from every chapter, okay? But not every day. In every chapter you'll be getting, I think, around 80 questions, and rest of the questions you can do from some books or some other material, okay? So yeah, for a book to study, so like to study, I can recommend you a book which is the, wait, I should write it with orange or maybe this blue one. So the book I recommend is Resnick and Halliday. Resnick and Halliday. So this is the book which I am going to recommend. This is a very good book for studying. Like this is not a good book, like this is not a book for solving questions, but this is a very good book which will teach you a very good theory. It will make your concepts look very good. So this is a very good book, and next we'll move forward. Okay. So yeah, so should we move ahead? So yeah, let's move. And one more important thing, that you should do all these things, right? So when you have made all these notes, after that you should practice a lot of questions, and those practice should be deliberate practice. You have to do it yourself with your mind. Like you have to forcefully make yourself do the practice. If you don't do the practice, then you won't be able to excel in physics or mathematics, because physics or mathematics need a lot of practice. Okay? You have to scribble your pen. You have to scribble down your pen a lot, many times. Scribble down means you have to solve a lot of questions. Okay. So what about H.C. Verma? Yeah, H.C. Verma is like a standard book for like JEE Main and advanced and all, but it is not a very good book. Like not a very good book. Yeah, it has some questions, but if you want to solve some questions from H.C. Verma, then you should solve the questions of the ending of the exercises. Initial questions, they are not very good. Okay. Yeah. So let's begin. So this is all about it. So let's begin. So today what we are going to study in basic mathematics. Today we are going to study, I think, should we start? Shall we start? Wait. Here we are going to start like. So is everyone good? So let's go. So we are going to start with basic mathematics, and this basic mathematics is going to start with functions. Now why I am starting with functions and not with vectors? Why I am starting with functions and not with vectors? If you see many educators out there, they might be starting with vectors or something different like trigonometry and all. Okay, so let's start. So now you all can pay attention. If you were not paying attention for last 30 minutes, then you can start paying attention right now. Okay, so now we are going to start with functions, because all the physical quantities, like some of you wrote down in the chat, then some of the physical quantities, they are like the study of physical quantities is physics, right? Like some of you wrote down in chat. So what are functions? Many of these physical quantities, they are functions of something. Like acceleration, velocity, they are the function of time. With time, they keep on changing, or like whatever they are the function of. Velocity is the rate of change of this displacement vector or position, and acceleration is the rate of change of velocity. So similarly, you can make a function of lot of things. Force is the rate of change of momentum. So everything in physics, whatever we want to ask for, they are actually a function of something. That's why we want to start initially with functions. So let's say we say y is the function of x. Let us say that y is the function of x. So what do we write it like? Y is a function of x. So what does a function actually mean? What does a function actually mean? If you want to know about a function, so let's say if we are having a machine, let's say if I make a machine right here, and if I give it a color of orange, okay, if I give it orange color, and let's say this is a machine, I call this machine as f. I call this machine as f. So function is basically a machine in which we are giving some input and some output is coming out. Okay. So there is a question. Please suggest a book for solving questions. Okay, I can suggest some book. Like you can easily download. There are various books. Like you can download DC Pandey for solving questions. You can download DC Pandey. You can download this book like Klepner and Kolenkov, David Morin. Like I'll be telling you. Right now we are doing just basic mathematics. You won't need any book. After we begin in physics, I'll be telling you a lot. Okay. So yeah. So function is basically a machine. Function is basically a machine in which you are putting some input, and from that input you are getting some output. You are getting some output, and this output is known as y, and this input is known as x. This input is known as x. So let's say this machine, if we consider it like, let's say what type of machine we can make. Like any machine you can take. If you want to make something, SciAstra book for solving questions. Yes, SciAstra book you can also take for solving questions, definitely. But yeah, there are little bit some errors might be there because that book is still under scrutiny. So like we are still looking at what are the errors over there. So yeah, you can look into that as well if you are having. Okay. So thresher. Okay, yeah, thresher can be used, but thresher is a weird example because some of you who are not into this farming and all stuff, they must not like couldn't be knowing this thresher machine and all. So yeah, let's say. So right now, wait. Right now, I'm not looking at the chat. Okay. So let's say we are having a machine. So let's say what type of machine I want to consider. We are having a machine, and in this machine we are putting some input, and we are getting an output. We are giving some input, and we are getting some output. So let's say, how many of have you ever watched anything? No, washing machine I cannot take. Washing machine is not a good example of it. So has any one of you watched like Factory Made, or there are shows like on Discovery Channel in which they say like you are having some, okay, oven. Okay, yeah, oven can also take. So yeah, there are some machines in which they make biscuits. So let's say if there is a biscuit making machine. Okay, if there is a biscuit making machine, so let us say, wait. So if I just give it over here, so dough. So let me get some photos first. So initially, oh my god, this is not faux. I wanted to write dough. So dough pics. Dough. Yeah. So yeah, this is a perfect example. This is a very beautiful example for our function. So let's say we are going over here. So yeah, this is our dough. So now just have a look at over it. Okay. So we are going to have an intuitive example. So let us just we are going to take it from here, and we are going to place it like this. We are going to take it from here, and we are going to place it like this. So this is our input. Okay, so we are taking some dough, and we are taking this. Okay, yeah, we can take some juicer as well. Yes, right, correct. Okay, so yeah, okay, so I asked you a question that how many of you have watched Factory Made? So there are some shows like Factory Made on Discovery Channel. So what do? They give us all these things, like they are telling us how do they make biscuits, chocolates and all. So all those things, they are very good examples of functions that they are putting some raw material. Okay, they are putting some raw material like this dough inside a machine which will make biscuits, and after that these raw biscuits, they are going to, like, whatever anything which is going to happen inside, that I don't know, they are going to get cooked, they are going to get heated up, and after that what we are going to receive is some output, and that output is going to be what? That output is going to be cookie. So cookie picture. So I think so, yeah, man. So this is gonna make me a bit, like, I don't know. Now I'm feeling a little bit hungry since I've looked at this beautiful cookie over here. So let us just cut it. So if I just cut it right here, okay, so this is the best example of a machine. Okay, so we made a cookie. So this is my input. What is the input? The input is something dough. Okay, so I put a dough inside, and this dough got converted into cookie. So what I put a dough inside, and this got converted into a cookie. Now what does this cookie depends on? This cookie depends on what type of dough I put inside, right? Is that correct? What type of dough I put inside will result in cookie. So this cookie is dependent on dough. If I don't put a dough inside, then this cookie is not going to get cooked. So this cookie is known as dependent variable. This is known as dependent variable. Dependent. This cookie is known as dependent variable because this is depending on dough. Is that correct? Is everyone okay with this? Tell me. Okay, yeah. So this is a dependent variable because this cookie is dependent on the type of dough which I am taking, right? And again, since this is a dependent variable, this dough is independent variable. This dough is independent variable. Why is this an independent variable? This is an independent variable because this is not dependent on anything. I can take any type of dough. I can take wheat flour. I can take ragi flour. Okay, I can take atta flour as well. Like atta is wheat, but I can take rice flour as well, which many of you from South India must be eating a lot of rice, right? So this is an independent variable and this is a dependent variable, and this dependent variable is dependent on independent variable. Is that okay with everyone, right? Okay, so now let's see. If this is my dough and this is my cookie. My cookie is dependent on dough, but my cookie is also dependent on what type of dough I choose. I cannot choose any type of dough, right? I cannot choose a dough which is rotten. I cannot choose a dough which is very bad smelly, right? Is that correct? The type of dough I want to choose should be clean. It should be clean, it should be free from bacteria and all, it should be very good, it should be healthy looking like this, right? So the type of dough which I can take, it is known as the domain of function. The type of dough which is allowed to take, it is known as the domain of function. So now we are going to get a definition for the domain. So wait, so here, do you have any questions until now? If you are having, then you can say any type of questions. So we are getting into mathematics with the help of this example. Okay, this is an intuitive, a very good intuitive example in fact. So domain, what is the domain of a function? So domain of x, if I want to say, so domain of dough is going to be like clean dough which is not rotten, right? This is going to be the domain. With rice flour you cannot make cookie. Yes, Nivedita, with rice flour you cannot make a cookie, but with rice flour you can make a dosa, right? So like this can be a tawa, this is rice flour, and this is going to be dosa. Okay, wait, you can make idli as well, right? So this is the, like, whatever idli maker it is in which the idlis are steamed. So this is the rice dough, this will be the idli maker, and this is going to be idli. So you can take it as idli as well. So this is just an example, right? So yeah, so now let's see. Domain of dough, it should be clean dough which should not be rotten. So this is known as a domain. Now what is the domain of the function of look like? Domain of x, okay? So domain of x, the domain of x is going to be all the allowed values of x. So this domain is going to be all the allowed values of x. So is that clear with everyone? That domain is something, the type of dough which we want to take, it should not be rotten, it should not be smelly. Similarly, there are certain values of x which we can take while going for a function. If I want to make, like, if you are from South India, you want to make idli. Idlis are made with rice dough. So for making idli, as Nivedita commented, I cannot take a like wheat dough, right? I cannot take wheat flour. So wheat is not allowed to make idlis, right? Wheat is not allowed to make idlis. That means wheat is not in the domain of making idlis. What is the domain of a function? Domain of dough is clean dough which is not rotten. Similarly, domain of x is all the allowed values of x. So is that correct? So in fact, domain of x, I should write it as domain of the function. Domain of the function is the allowed value of x. So domain of, I should write it as function, because it is not the domain of x, it is the values of x, but the domain is the domain of function. That in the function, what are the things which I can put inside the machine? Inside the idli maker, I can put only rice flour, not wheat flour, right? Correct. So after that, this is the domain. Now let's see, if we go on to this pic, if we move on to this pic, wait. So if we move on to this pic, just back, a little bit back. I don't know what's wrong. Okay, this is dough. So yeah, I wanted to go to this picture. There were some multiple doughs. So let's say there are some, you can see multiple doughs over here, right? There are multiple doughs over here. So, okay, so someone commented there is wheat idli. Okay, I don't know about wheat idli. I'm from North India, I'm from Himachal Pradesh, so I don't know about idli. So I take my words back. Okay, so let's come back to cookie only. Okay, so let's see. Okay, so the domain of X is dependent on the output of Y or the function we would use. The domain of X is dependent on the output. No, the domain of X is not dependent on, domain of X is nothing. Domain of function is something. Domain of function is the values of X which we are taking. Domain of function is the value of X which we are taking, and those are not dependent on Y. Those are not dependent on anything. Those are dependent on X itself. That the type of dough which you want to consider, it should be clean dough. It should not be rotten. It should not be smelly, right? Is that correct? So see, now just think logically. If I'm having 1, 2, 3, 4, 5, 6, like 1, 2, 3, 4, 5, 6, 7. Okay, I'm having 7 pieces of dough spheres over here, right? I'm having 7 pieces of dough spheres over here. So how many cookies am I going to get after this making these 7 spheres? How many cookies I'm going to get after these, after putting these 7 spheres inside that machine? Tell me in the chat. How many cookies I'm going to get after putting these 7 spheres inside that dough making machine, cookie making machine? Okay, 7 cookie, right? So all of you, like many of you, not all of you, but many of you have written 7. So 7 cookies will give us 7 outcomes, right? So as many number of cookies, as many number of independent variable I'm putting inside, as many number of dependent variable are coming. So for each independent variable, I'll get one output. Is that correct? For each independent variable, for each dough, I'm getting one cookie, right? For each dough sphere I'm cooking inside, I'm getting one cookie. So that means there is something which is depending. So I can write it as the range of function. So this is going to be the range of function. So not of function, I'll say the range of this cookie. So, and in fact, range of dough instead of dough, I can write is cookie as well, because in our case it is cookie or whatever. So range of cookie. So what can the cookie be made of? So what can the cookie be made of? So yeah, what is the range of cookie? The range of cookie is going to be similar as just like the range. So yeah, you are having any doubts? Okay. So range of the cookie, as many number of doughs are there, as many number of cookies will be there. Okay. So range of cookie, all the cookies which can be obtained from dough, from the given dough. So all the cookies which can be obtained from the given dough, which will be the range of cookies, and what will be the range of function? What will be the range of function? So range of function is going to be all the possible values of y. Simple. So all the possible values of y. So is that okay with everyone? So is everyone clear with the concept of function? Tell me. Is everyone of you clear with the concept of functions? What is a function? We have some input which is independent variable. We put it inside a function which is a machine, and what we get? We get an output. So wait, let me paste a pic of machine as well. So cookie machine. So let me paste a pic of this thing as well. I think this will, oh, this is very good. This is actually very good. This is a very beautiful machine. I think this will be a very good example. So I'm going to use this. I'm going to go to desktop. I'm going to slice it from here. So wait, I just should take this one, right? So is that good? We are putting this is my machine, I am putting something inside it, and I am getting some output related to it, correct? So is everyone clear with this? Now we are going to move to some more mathematical definitions. So this is what a function is, right? So now let's see. Now let us see what does a function looks like. What does a function actually looks like? So let us try to make some graphs. So today we'll be doing some graphs as well. So how much time is left? There's still 45 minutes, right? So let's see. We are making this. Should I make in some other? Could you please give a question to understand this topic? Yes, I'll be giving you questions, Atul Krishna. I'll be giving you questions, but right now I'm again on some explaining, right? So number in domain equals number in range, like 7 domain in 7 range. Exactly, Toshini. Exactly, this is the thing which I'm going to come. Like I was going to come right now. Okay, so we just wait. So let's see. So can I make something over here? I want to make something over here because I want to use as much space I can. So wait. Oh, so I should be making it like this. So let's say if I'm giving it blue color, I'm giving this one blue color as well because I love to use. Okay, so one thing which I wanted to say is that I think I told you this in live class as well, that in my class you are going to see a lot of graphs. Like in my class you are going to see a lot of graphs, and those graphs are important. Those graphs are important because with graphically you can help in better visualization of these images, like whatever you want to see. Physics is better visualized using graphs, graphically. So it's better to use graphs. And whenever we talk about functions, whenever we study about functions, we always use graphs because functions are best studies using graphs, right? So let's say if we are given some graph over here, let's say we are given some graph like this. Okay, if we are given some graph like this, so did you study some graphs in class 8th or 9th? I think you must have studied, right? Making some graphs like y is a function of x. So this is how we write y as a function of x, that we plot some values of y for the values of given x, right? Have you done this in class 8th or 9th? Tell. Yeah, right? So let's say we are given some graph. So not every graph is a function. Always remember, not every graph is a function. So one of you said, her name was Toshni, her or his, like whoever. So Toshni, she said that for 7 dough we are going to get 7 cookies, right? That is absolutely correct. That's why I showed you that pic. For 7 dough you're going to get 7 cookies. So as many number of cookies are there, as many number of outcomes you're going to get, right? So for each cookie you're going to get only how many outcomes? 1. Is that correct? For each cookie you're going to get only 1 outcome. That means for 1 value of x you can get only how many values of y? 1. This is the most important line for a function. This is the most important thing for something to be a function. So for this graph to be a function, for each value of x you should have only 1 value for y, right? So let's say if I am taking some value like this. So this is a very important thing. Let's say I am taking a value like this, okay? I'll take a value like this, I'll take clone of it, and I'll make a value right here as well. So let's say if we are making 2 values right here, just like this, okay? So I'll be writing it as, this is my x1 point, this is my x1, and this is my x2. So at x1 I'm getting a value of y. I'm getting a value of y. Let's say this value is y1. At x1 I'm getting a value of y which is y1. At x2 I'm getting a value of y which is y2. So at each x I'm getting only 1 value of y. That is unique value for the function. So if I'm getting for each x I'm getting just a unique value of the function, then that graph is known as a function. Like then this graph is a graph of a function. Then how I can call it as that this graph is a function, represents a function. So this graph represents a function. Y is a function of x. If my graph is having multiple values for single value of x, then this won't be a graph of function. Is that clear with everyone? Can I move on with a little question? Say, can you write down in chat? Okay, wait, I'll just come with, I'll fill my water bottle and I'll just come back in a second, okay? Wait. Okay, yeah. So I'm in with my bottle. Okay. So an example of multiple values. No, we cannot. A function is always having one value, one outcome for one. Like for one biscuit, you are going to get only one outcome. So is that clear with everyone? So for each value of x, we are getting only one value of y. So yeah, let's move ahead. So this is all about domain and range, right? So we are done with domain and range as well. I'll just mark it with some pink. So this is my domain and this is my range. So let's go to next slide. So which graph among these are represent function? Represent So which graph among these represent function? We want to know. Okay. So let us give you some graphs. So I should be using this blue line. This is my blue. I'll clone it. I'll make another one right here. I'll clone it. I'll make another one right here. And I'll place it a little bit backwards. Oh my goodness, it just got carried away. So it should be right here. Delete. I'll give it blue color. I'll give this one blue color as well. Okay, come on. Blue color. So yeah, is anyone of you having any doubts? You can write down in comments. Meanwhile, I'll make these graphs. So if you are having any doubt, you can write down it in comments. Okay, so these are going to be my graphs which I'm going to give you. So let's say we are having this is as y-axis, this is my x-axis, this is my y-axis for second one, this is my x-axis for second one, this is again my y-axis for third one, this is my x-axis for third one. So yeah, is everyone having any doubt? Sine curve is a function, sir. Okay, so yeah, you drink water, good. So Nivedita, sine curve is a function. You can ask this question yourself. So is sine curve a function? Ask this question yourself. We'll be doing it in, I think, in next class probably. So meanwhile, you can ask that question to yourself. So is sine curve a function? You can try making the graph of sine curve, and you can see how many times a straight line cuts it. So if a straight line cuts it many times, then it will be a function. If a straight line doesn't cut it many times, it won't be a function. So let's say if you are given these three graphs over here, okay, is it necessary for all element in domain to be in range? No. Arya Bibaswan. So okay, I'll call you just Arya. So Arya, is it necessary for all elements in domain to be in range? No, you're actually asking a little bit misleading question. For every element in domain, if you are putting something inside a machine, you are definitely going to get an output, right? Like if you are putting some biscuit, if you are putting some dough inside, if you keep that dough long enough in the machine, then it will come out as burnt, like burnt biscuit. Again, that biscuit will be burnt, but still it is going to be an outcome. So for every every point in domain, you are going to get something in range. So this is what domain is. Domain is the allowed values of x. So what are the allowed values? Something which can go inside that machine. You cannot put a rice dough inside a cookie making machine, because let's say we are not having rice cookies, right? So if we are not having any rice cookies, then you cannot put rice inside this machine. So all those values which are allowed for x, they make those values for y, right? Okay, wait. So Rugo, next one. So wait, there was more question. Wait, I'm looking in the chat. So one output can have many inputs, right? One output can have many inputs. One output can have many inputs. Is it possible that many inputs can have one output? Is it going to be possible? Just see yourself. Sir, if 1x value, it is a function, but for more than one y value, it is a function. Yes. So yeah, this is a question. This is what we are going to see. So Atul Krishna as well as two of the students which you asked, Toshni and Atul Krishna. Your answer is going to be answered by this question. So yeah, let's see which of these following are functions. So what do we do? We'll see. So this is known as vertical line test. This is known as vertical line test. What do we do? We make a vertical line like this and we see how many times does it cut this graph. Okay, I'm saying graph, not function, right? So we make a vertical line and we say how many times it cuts the graph. So cuts, intersects, or touches, whatever you can say. So here we can see that it cuts the graph at how many points. So if it cuts at only 1 point, then it is going to be a function. If it cuts at more than 1 point, then it is not going to be a function. So here it is cutting at 2 points, right? Cutting or intersecting. In the language of physics or mathematics, we can say intersecting, right? Here it is intersecting at only 1 point. Here it is intersecting at 2 points. So which of these are going to be a function? This is not going to be a function because here it is intersecting at 2 points. This is going to be a function, definitely. This is not going to be a function. So is that clear with everyone? This is the thing which I told you in this slide, that the functions are functions is those graph which are which are having only one output for one input. When we are putting one dough, then we are getting only one biscuit. So this is going to be the case, right? Is that clear with everyone? Yeah. So this is the thing. So we can write it as, so how much time is left? Wait. So there's still half an hour, so I think we can move ahead a little bit more. So yeah, we can write it as this y is not a function of x. This y is not a function of x. This is one is y is a function of x. This is a function of x. And this one again is not a function of x. So tell me, is everyone clear? So this is known as vertical line test. So this is known as vertical line test, and if we are having only one intersection, with graph, if we are having only one intersection with graph, then it is a function. So this is known as a vertical line test. And this is a very basic test. Why this is a very basic test? Because this is actually based on the thing which we studied earlier, that for one input we should have only one output. Here you can see for one input, okay, so for one input for x1, let's say if I call it some x naught, if I call it some x naught over here, if I call it some x naught over here, if I call it some x naught over here as well. So for this x naught you are having two outputs, right? Here you are having two outputs, y1 and y2. So here you are having two outputs which are y1 and y2. This is y1 and y2. So how is this possible that you are putting only one dough sphere inside and you are getting two biscuits out of it? That is not possible. That's why this thing is not a function. So is that correct? So can we have multiple outputs for a single input? No, yes, that won't be a function, Ashley. Yes, exactly. If you are having a single input, you are having two outputs, then it is not going to be a function. Similarly, it is the case in this one as well. So it is the case in this one as well, that we are having two outputs for a single input. And when you will be going in IISER, NISER, IISc, or wherever in some national institute, you will be getting some functions which are multi-valued as well. But for the sake of class 12th, or like for the sake of these exams, we won't be studying those things because those are some higher level things. Those things you will be studying in IISER. So yeah, and this is only 1 point. This is only y naught, I can say. Okay, so is everyone clear with this one? This is what all about a function is. Okay, so let's go for it. So now let's go to some graphs of some functions. Let us go to graph of some functions. So now we'll study some graphs and then we'll end the class. So I'll be telling you the graphs of these functions because these functions are pretty important. Pretty important in the sense you will be using these functions a lot in physics class, even before your mathematics class, even before you study these things in mathematics class, then you are going to get it. Okay, so Nivedita, I got confused with for every pi by 2, 5 pi by 2 we get 1. What do you mean for every pi by 2, 5 pi by 2? Yes, definitely you get 1. You get 1, but for pi by 2, what does sin x looks like? Sin x is like this. We are going to study it. Okay, this is pi by 2, this is pi, 3 pi by 2, 2 pi, 5 pi by 2, right? So for 5 pi by 2 and pi by 2, you are getting 1. But those are different values of x. Those are different angles. This is pi by 2, this is 5 pi by 2. So this is a function. Why this is a function? Again, if I take this, my white line, this my white vertical line, at any point if I cut sin x, this is going to cut at only 1 point. That's why sin x is a function. This is the most important function which you are going to study in physics, besides exponential function. Okay, so yeah, we are going to study it. So is that good? So yeah, let's go for it. So let us go with the first function, which is y is equals to x squared. Y is equals to x squared. So if you are having any problem with some terminology which I am writing, then you can directly ask. Okay, you can directly ask in chat, because like if you don't know the terminology, then it's going to get a pretty messy. So to make it messy and to make it as much streamlined as possible, you should be knowing all the terminologies which I'm using over here. So I'll be using pretty like some mathematical terminology as well. Do you know this symbol? How many of you know this symbol? Have you seen this like flipped E? What does it convey? What does it express? Okay, Divya Yadav, for different values of x, you can get same value of y. Absolutely. For different values of x, you can get same values of y. Okay. So no, right? So this is known as there exists. There exists. You need not to write it down. I'll make it like, I'll write it in, yeah, Tanika exactly. So this is there exists. So you will be having a lot of notations like this, okay? And I'll start using these notations over here, okay? So let's go for it. So the first graph is the graph of y is equal to x squared. So this is what it looks like. I have to make it a bit cleaner. So I want to make it as much clean as possible. Again, it is not that clean. So yeah. I think I should make it first, then should make the axis. Oh, wait. Okay, I think now is it a bit cleaner. So you are having a class after that?
No.
Okay.
You can use also function fx, click on
Okay,
fx.
there are functions.
Yeah.
Okay.
Just.
Okay. So your mathematics sir just told me that I can take some functions from here as well.
Select entire directly.
But yeah, but just leave it. I'd rather make it with my hands because it's pretty difficult. Okay. So yeah, we should have the habit of making the functions from hand as well, because in the exam you won't be having any computer and all. Okay. So this is my y. This is my y. This is my x. And now this is a function of x. So this is the graph of y is equal to x squared. This is the graph of y is equal to x squared. Right? So wait. If we rotate the graph 90 degree, will the vertical line test become a horizontal line test? Actually, we actually always take the dependent variable always on the y-axis. We always take dependent variable on the y-axis. But yeah, if you rotate the graph by 90 degree, then the horizontal line test will be, vertical line test will become horizontal line test. But we always place independent variable in x-axis and dependent variable on y-axis, because we always write y as a function of x. If we want to write x as a function of y, then definitely it is going to become a horizontal line test. So it will always depend on the type of coordinate frame which you are choosing. If you are choosing something as a function of this, if you are changing it in a different sense, if you are just flipping it over, then you will be using something different, and that is known as like, what do we call it? Is we call it inverse of a function. So we are going to do inverse of a function as well. Okay. So yeah, and this y is equal to x square in my language. In my language, I called it a U-shaped graph. A U-shaped graph, just for understanding and just to keep it in mind, that whenever y is equal to x square comes anytime in like in our life, I can call it U-shaped graph. And this graph, this function passes through origin. This function passes through origin both x and y axis, it passes through origin. And this is U-shaped. You won't find it anywhere in the book. Maybe you might find it somewhere in some book and all. But this is just my way of speaking, that I just remember it by saying that this is a U-shaped graph. Okay. So now let's talk about its domain and range. Let's talk about its domain and range. So domain. What is going to be the domain of this function? So now, do you know about the symbol? So let's talk about the symbol first. Do you know about this symbol, this small e? Do you know about this symbol? Have you studied it in mathematics in sets in class 11th or something? So if you have studied it, then please write it down. If you know, then I'll tell you. Tell me. Belongs to, right? So is everyone okay with this, right? I can use it? Okay, correct? Okay, correct. So I'll be using it. Okay, so I need not to tell it. Epsilon, no, it does not epsilon. I am using it for belongs to. Okay. So the domain. What is the domain of this function? What are the values which I can put inside x? So I can put every value inside x over here. Okay. So the domain, it is going to be all real numbers. The domain is going to be all real numbers. And what is the set of real numbers we express like? The set of real numbers we write like this. We make two lines like this and we can write capital R. This capital R, this tells us that this is telling us this is a real number. Like this is a set of real numbers. So yeah, Fatima, this graph, the one called parabolic. Yes, this is a parabola. We'll be studying parabola as well, but for this, like, for now, like, I'm not calling it, giving it any name, right? But this is a parabola, yes, right? Okay. So this is domain. Now, what is the range? What is the range of this function? If we want to look at the range, now what is the meaning of range? The range was what are the values of y which we are going to get. Now range is very easy to look when we can visualize it graphically. When we look at graphically, so it is a R with line, yes, exactly. So yeah, wait. So when we look at the range, we can look at very easily that we have to just look at the graph. Where is the graph going? Like in the y-axis, where is the graph going? So here the graph is going from 0 until infinity. Again, here the graph is going from 0 until infinity in y-axis. So wherever the graph exists, that is the range of y. Okay, so this is very easy. So the range here, it belongs to, from where? It belongs to 0 to infinity. So this is going to be the range. So is everyone okay with this? Can we move it? Yes, we can call it R plus as well. But range is not only R plus. Range is R plus with 0. Range is R plus and including 0 as well. Because we are getting 0 as well over here, right? So is everyone okay with this one? Should we move to the next one? Okay. So next one is the graph of y is equals to 1 upon x. So second graph which we are going to do is the graph of y is equals to 1 upon x. So what is this graph going to look like? So let me make it a little bit faster because class is progressing forwards. So we have to increase the speed a little bit. So let's make it. So what is this graph going to look like? So this is my y-axis. This is my x-axis. What is this graph going to look like? If you like give a closer inspection at it, then you can see as x increases, as my x gets bigger, the y keeps on getting smaller. So as my x increases, my y starts decreasing. So as my x increases, my y starts decreasing. This graph is going to look like. And again, this is going to be symmetrical on this side as well. So I should make it like this. This is my graph going to look like y is equals to 1 upon x. And this graph is not going to pass from any point on any axis. Whether origin, any point, graph is not going to pass through any point. So this is my graph for y is equals to 1 upon x. So is everyone okay with this one? Right? This is my graph for y is equals to 1 upon x. Now let's try to find its domain and range. Let us try to find its domain and range. So what is the domain going to be? Domain belongs to. So here we can see, whenever we try to find some domain and range, we have to look that what are the values of x which are allowed. What are the values of x which are allowed over here? Here we can see the x is in the denominator. So in denominator, the denominator should never be 0. Nidhi, it cuts y-axis at 1. No, it doesn't cut y-axis at 1. Where is it cutting at 1? It is cutting nowhere. Okay, yeah. So domain is r minus 0, correct. So what is domain? Domain is something, okay. So always remember, whenever looking at the domain, you have to look at 2 points. Okay, 2 points, I'll say. Domain is always going to be r. Whatever is the case, domain is always going to be r. Only those points in the x you have to remove which are having, which are making the denominator 0. Because if the denominator becomes 0, the value blows up. Because what happens? Let's see. If the denominator becomes 0, let's say if I am placing 0.1, this will become 10. If 1 upon 0.01, this will become 100. 1 upon 0.000001, this will become very big, right? So if I place 0 in the denominator, like very close, whenever I'm getting closer to 0 in the denominator, the numerator is blowing up, it is becoming very big. So if I place 0 in the denominator, if it becomes 1 upon 0, if it becomes 1 upon 0, then it is going to go towards infinity, right? It is going to blow towards infinity. And infinity is not a number. Infinity is nothing which we can comprehend. Infinity is nothing incomparable as well. Okay. Infinity is something like godly. It is actually godly. We don't know anything about infinity. Even in still, like even in this era, mathematics, they are studying about infinities. When you will go into IISER, you will be finding various like algebraic geometrists which are going to like study about different types of infinities as well. Like some infinities are bigger than other. Okay, so these are the infinities. So we don't talk about infinities. That's why whenever the denominator becomes 0, those points you are going to exclude. So here domain is going to be all the real numbers minus 0. So yeah, many of you answered already before I answered it. So why is this r minus 0? Because denominator should not be 0. So here I can write it down like this, that because, so I can write it down, because denominator can't be 0. So denominator cannot be 0. Okay, do you know this notation which I used it over here, this 3 dots? What are these 3 dots known as? These 3 dots are known as because. Okay, these 3 dots are known as because. These upside down triangle. Okay, so yeah. Okay, I have a doubt. Why we write I minus? Why don't we write just normal r? We don't write normal r because those are the notations which are used by mathematicians. Capital R can maybe used for some other thing, but this double line r, it is used for showing a set of numbers, set of real numbers in fact, right? Okay, so this is because. Yeah, because or since. These 3 dots you can write it as since or because, it is the same thing. Okay, so this is the domain. Now what is the range for this function? So what is the range of this function? The range of this function is going to be, see, the graph of this function is going from infinity, then it is going towards 0. And here it is going from minus infinity and going towards 0 again. So graph of this function is going from minus infinity to infinity. Just one point is excluded, that is 0. So here we can write the range again as r minus 0. So here we can notice that the range and the domain, both the range and domain of the function are same. Is that okay? Like, is everyone okay with this one? Then we'll move to the next one. So is everyone okay with this one? We can move to the next one after that. I think this class going is to extend a little bit. Okay, is everyone okay if I extend the class a little bit, like 10 minutes or more? I might extend it, okay? So let's see. Now I want to talk about something more over here. I want to talk about a little thing over here, which is this thing. Which is this thing. Which is this thing. So pay a close attention to it. This is known as asymptote. asymptote. This is known as an asymptote. We call it as an asymptote. What is an asymptote? Asymptote is something where the function is trying to reach some value, but it is never able to reach that values. Let's say if we are having some parallel lines, then parallel lines, they are not going to meet, right? Okay, you have a next class from 11:40, right? Okay, so you have a lot of time until 11:40. We'll be taking class until 11:40. Just no problem, right? So 11:40. Right now the time is 11:18. Okay, Toshni, why not minus infinity to infinity for range? Toshni, you can see this is not going from minus infinity. Okay, Toshni, I'm coming on to your point. I'm coming on to your point right now, that why we are excluding 0 from here. We are excluding 0 because this is actually not taking the value of 0. Just see. Okay, Toshni, have a look over here, right? So this point is known as, okay, so, okay, first of all of you just see here. Have you ever seen parallel lines? Parallel lines are like this. Okay, they are always parallel, they never meet. Like they are never making a triangle or anything like this. They are always at equidistant from each other, right? So have you ever seen like this when we see a track, when we see a railway track? Wait. So when we see a, so I want to make you feel this thing. So let us try to visualize this thing. So, oh my God. I want to get an image. I hope I should get an image. This Bing truly sucks. Okay, so yeah, this is the thing which I want to tell you. So this is an important thing which I want to convey. So let's go over here. So let us say, I should just cut it. So I'll just take your class a little bit longer, just a little bit longer. You can just see it, you can feel it, you can enjoy it. Okay. So this is the thing. Okay, so have a look at it. Have you ever seen something like this? Have you ever seen something like this? Have you ever seen something like this? Yeah, exactly. These railway track, they appear to meet, but they are not actually meeting. They are not actually meeting. They are always parallel, right? They are always parallel. These railway lines, they appear to meet, but they actually don't meet. So this is known as an asymptotic behavior. Actually, this is not even, yeah, this is an asymptotic behavior because they are actually going towards each other, but they never meet. This is known as an asymptotic behavior when the graph of a function is approaching somewhere. This is approaching somewhere, but it is not taking that exact value. That means what I want to say here, just have a look at over it. You will be studying it in mathematics as well. So when my x is approaching infinity, when my x is going towards infinity, my y is approaching 0. What my y is approaching? My y is becoming, not becoming. In fact, this is approach. Okay, this is, we can say this is approaching. Okay, this means approaching, but not exactly. Okay, but not exactly becoming 0. So this is the thing which I want to, oh, so but not exactly becoming 0, right? So sir, will you be having a class at 11:40?
No.
That's good. So yeah, so wait students, you just see it over here. Okay, I'll make your next class be scheduled 10 minutes after that. You just keep your attention over here. So yeah, so this y is approaching 0, right? Just see this y, this is the function of y, right? Okay, this is the function which is coming like this, and whenever this function is going towards x-axis, it is just going near it, just like these two railway lines. They're approaching towards each other, but they actually never meet. Just like that, this is known as an asymptote. So this is why I placed a pic over here, that this is an example of an asymptote. Is that okay with everyone? They appear to meet, but they never meet, and they actually are getting closer to each other. Like in this pic, you can see they are getting closer to each other, let's say for our eyes, even though actually they are not getting closer. But these two graphs, like this axis and the graph, this axis and the function, they are actually getting closer to each other. But again, if you zoom it in, then you will again see some difference, like some distance. Okay, so this is a very best example to explain an asymptotic behavior. So these things, when x is approaching infinity, the y is approaching 0. Now coming back to one of the students, I think who was, wait, so Atul Krishna, why is r minus 0 not the answer? Okay, so Atul and one more student asked, why is r minus 0 the answer? Why in the range 0 is not included? 0 is not included because we are approaching 0. We are not getting exactly the value 0. Is that clear? Tell me. Is that clear with everyone? That we are not including 0 because it is just approaching, right? Now let us compare it with this one. Here, the graph is actually cutting at origin. The graph is actually becoming 0. That's why we are including 0. That's why we are including 0. This is a square bracket. Square bracket means we are included that value. If this is an open bracket, then we are not including that value. Whenever we write infinity, we never include it because infinity can never be included, right? Is that clear? Let's move to the next one now. So this is 1 upon x. Now we'll do similarly 1 upon x, we'll do 1 upon x square. I'll do it a little bit faster because, yeah, I know you are having next class as well. So third one is y is equals to 1 upon x squared. So I'll just make it a little bit faster because it's pretty similar to the previous graph. So let's have a look at it. So this is my blue, and again this is my thing like this. This is going to be yet another blue. So let us make it like this. This is my y-axis, this is my x-axis. So what is my y is equal to 1 upon x square graph look like? It is going to look like this, and it is going to look like this. So this is a very highly symmetrical graph, okay. This is a highly symmetrical graph. Y is equals to 1 over x squared. Y is equals to 1 upon x squared. Now what is the difference between y is equals to 1 upon x squared and y is equals to 1 upon x? The only difference is the squared, and the decay rate of the function is same. It is decaying in the similar manner just like this function was decaying. But this y is equal to 1 upon x squared is decaying much faster, right? Now let us look at the domain in range as well. Let us look at the domain in range as well. So domain belongs to, where does the domain belong? The domain, again it is going to be the same. Domain is going to be r minus 0, because here as well we cannot include 0 because the denominator should never be 0, right? Is that okay? If we go to the range, what is the range going to look like? If we talk about the range is going to change now. The range is going to change. The range is going to be 0 to infinite, because here again we are approaching 0, but we are never becoming 0. So this is going to be 0 to infinite. So range is going to be only positive. Now see over here. Here again I am not including 0. Why I am not including 0? Because 0 is not included over here. Right? Correct? Is that okay with everyone? So this is our domain and range for this function. So I think how much we'll do today. So I'll make you do just 3 more functions today, and then we'll end, okay? So the class we were having from until 11:30, right? So we have still 4 more minutes, and after that we have 10 more minutes. So 14 more minutes. So let's continue. Are you guys tired, or are you guys tired or sleeping, or are you okay with this? So we can refer to this range as r plus. Yes, Srishti, we can refer to this range as r plus as well. Yes, correct. So now let us write one more function, y is equals to mod x. Okay, y is equals to mod x, and this is known as a modulus function. What do we call y? How do we like split it? This is mod x plus x when x is greater than equal to 0, and this is minus times of x when x is less than 0. This is how this function behaves, mod x. Okay. Why the range is not minus infinity? Kunal, why is the range not minus infinity? What is the meaning of range? Here it is x squared. When my function is taking only positive values, like it is making all the values positive, then how can the range be negative, Kunal? Right? So this is going to be like this. So let's come to this function. So let us make this graph pretty fast again. So because I want to at least reach up to exponential function and one more until today, then we'll be doing some few like other things tomorrow. So this is my blue one. So these are all the graphs which you have to like remember by heart. You don't have to cram it, you don't have to learn it, you have to just understand the actual real basic understanding. So these graphs are going to look like this. This is at 45 degree. Okay, nice. So we can make angles as well. So and again yet another one I can make like this at an angle of 135 degree. Correct. That's absolutely perfect. And this angle is going to be, theta is going to be 45 degree. This angle is going to be 45 degree. So this graph is going to behave as y is equals to x over here. So this total graph is y is equals to mod x. This is the graph of y is equals to mod x. And this graph is actually split into 2 parts. This graph is actually split into 2 parts. Here it behaves that y is equals to x, which is written over here, y is equals to x at x positive. And here it behaves like y is equals to minus x. Y is equals to minus x. Okay, it behaves like this. So yeah, you guys are okay, right? So we'll be moving ahead. So this is the graph of this function over here, and in my language I call it a V-shaped graph. Just to remember it, the modulus function, I call it a V-shaped graph because this looks like a V shape. So V-shaped graph, and this is known as a modulus function. This is known as modulus function. And what does modulus function do? It makes every negative thing positive. So basically, if the input is negative, again it is making it positive by putting a negative sign outside. So totally it will always become positive. And one more thing which we can notice is that it is passing through origin. So let us look at its domain and range as well. So if I want to look at its domain and range, then what it is going to look like, the domain is going to be all real numbers because I can put everything inside it. Domain is going to be all real numbers. Range is always positive, and range is going from 0 included up to infinity. So this is going to be the range, and this is going to be the domain. So is everyone okay with this one? Can we move ahead? Right? So I still have 2 more graphs to make. So we'll have done this. Is it looking symmetrical? Yeah, this is good as well. So let's move ahead. So I should write origin here. So I should write this as origin. So let's move ahead. So this is our 8th slide, okay, and this is our 5th graph. This will say one of the most important graphs. Even in fact, you can say this is in fact the most important graph of physics. Y is equals to e to the power x, and in fact mathematics as well. This is known as exponential function. We call it exponential function. We call it as exponential function. We call it exponential function, and the value of e. The value of e is around 2.7, and it is an irrational number. The value of e is around 2.7, and it is an irrational number. And we won't be going to any history of e and all because you will be studying that in mathematics, but this is a very important graph for the sake of physics if we write it down. So let us try to graph it. What does it look like? How does it behave? So this is our blue, and again this is going to be yet another blue one. So I'm going a little bit faster now because time is also moving pretty fast in the end of the class, but still I'm going to take just 10 more minutes of yours so that we complete at least this much, because today class was not going to be only about giving some wise thoughts and all and preparation strategy. This is going to be study as well, okay? So yeah, y is equal to mod of x, mod of 1 upon x is equal to 1 upon x square. Toshni, no, y is equal to mod of 1 of x is not equal to mod of 1 upon x square because those graphs are going to be different. 1 upon x is actually decaying in a different manner. 1 upon x square is decaying in a different manner. Yes, those are going to be positive, but those graphs are not going to be same, okay, because those are actually different functions. So what this graph is going to look like, what this function is going to look like, y is equal to e to the power x. This function looks like this, okay. This function looks like this. Now what is this point going to be? This is my origin, and what is this point? If I look at this point is going to be 0. E to the power 0 is 1. So at 0 this value is going to be 1, right? Is that okay with everyone? So this is our graph of y is equals to e to the power x. Y is equals to e to the power x. So this is our graph for y is equal to e to the power x. Again, here we can see this is behaving as an asymptote. Is it? This is behaving again as an asymptote. Why is it behaving as an asymptote? Because when x is tending to minus infinity, then e to the power x is tending towards 0. Correct? Is that good? When x is tending to minus, graph of our session schedule. What do you mean? So could you show the 4th graph again? Which one was the 4th graph? This is the 4th graph. Okay, Kumar, Amritanshu, you can look at the graphs after you will get the slides. Right now, let me just complete it. Okay. So because 11:33 is almost there, we are having 7 more minutes until your next class start. So let's look at it. So this is known as an exponential function. Okay. Now, what is, okay, so I was talking about this asymptote. So about this asymptote, just look at it, have a look at it cautiously. When this graph is moving from x to minus infinity to x to 0, in this thing we can see this graph is moving very slowly. This graph is growing very slowly, right? This graph is growing very slowly between x to minus infinity to x to 0. And after x to 0, this graph just shoots up very fastly. This is known as exponential growth. Exponential growth. Initially, it is very slow, very slow, very slow, and then after that it grows very rapidly. This is known as an exponential growth. Okay, and now let's look at its domain and range, and why this graph is important. We'll talk about this as well. Let's talk about its domain and its range. So its domain is all real numbers. We can put anything inside it, right? So all real numbers, and range is from 0 to infinity, right? 0 to infinite. And here 0 is not included. Why? 0 is not included because it is approaching 0. E to the power x is approaching 0 when x is approaching minus infinity. Is that okay? So I meant you making this procedure study first only then. Yes, Kumar Amritanshu, exactly. This is I was saying in that class that initially we'll be studying like this. We'll be studying like this from 0 to 1, like minus infinity to 0. We'll be studying very slowly, and after that, when we cover all the basics, we'll shoot up very rapidly because you have to cover 2 years of syllabus in less than 1 year, right? Okay. So yeah. So this is known as, so again this is an asymptotic behavior. Now why this behavior is important? Why this behavior is important? Because these graphs, we can see these graphs in population growth. The population grows in this way. The population grows in this way, like human population in 1970s it was somewhere around like whatever it was 4 billion or something. Now it is 8 billion. Then it is predicted like by 2032 like or something like it will be 32 billion. So the population, it grows very rapidly. Even if you see the cases of COVID-19, right? The cases of COVID-19. The first case which came in Kerala, she was a student from he was a student from China, right? So like he came back from China, and somehow like the virus came along with it. Like she or he became infected, and after that the cases after a month they grew like 3 lakh. So the cases grew exponentially. Initially there was only one case, and then those cases they also grew exponentially. So can you tell more about asymptote? Yeah, I can tell you more about asymptote. We'll be learning it in next class. So are graph of log and exponential same? No, graph of log and exponential are totally different. They are actually the inverse of each other. They are inverse functions of each other. That's why they are the similar graph. The log is just like this. Okay, we'll be doing log as well. Okay, so next thing we can see over here, population growth. Next thing is bacterial growth. Bacterial growth as well. And next thing which I can write down, like all those chemical reactions, chemical kinetics which you will be seeing. So chemical kinetics, I think probably first order reactions. So chemical kinetics, you will be having some reactions which are having first order reactions, they are having exponential decay. Like all those reactions they get in an exponential way. Now I want you to look into Google. So like there's something like there's a person whose name is Bartlett. So there is Bartlett, Bartlett Beaker. So there's a mathematician Bartlett who said that let's say if I'm having a bacterium, just a single bacterium, and I'm putting that bacterium inside this like whatever this thing is. So this is like something utensil. So I'm placing this bacterium inside a utensil, and that bacterium is. You are having a lecture?
Yeah.
At what, 11:40?
11:40.
Okay, I'll be just okay. I'm taking 5 more minutes, right?
Okay, no problem.
So yeah, 5 to 7 more minutes. Yeah. So if I'm having a bacterium at time t is equal to 0, and if that bacterium it starts growing in an exponential way, like it starts dividing into twice. Like at t is equal to 0, that bacterium is having one population, right? At t is equal to 2, it is getting 2. At t is equal to 3 seconds, it is getting 2 square. Then 2 to the power cube, 2 to the power 4. So this is how my bacterium is growing, right? This is how my bacterium, yes, nuclear decay as well. but nuclear decay, it is exponential decay. Here we are talking about exponential growth. So I want you all to search about this like Bartlett beaker, so you can search it on Google. So what did he say? Let's say at t is equal to 0, at time t is equal to 0, I'm placing a bacterium over here and it is dividing into twice, like twice is the rate of its division. So it is dividing every minute. So let's say at t is equal to 59 minutes or seconds, like whatever. Let's say every second it is dividing. If it is dividing every second, so at 59 seconds, at 59 second it is going to fill half. Okay, it is going to fill this beaker by half. Now what amount of time it is going to take to fill this beaker full? So I studied it in biotech at school. Okay, that's very good. So that's really good. So at 59 seconds it is going to fill half. At what time it is going to fill totally up to the brim? What time it is going to take to fill it fully? So it is going to take only 60 seconds. So in last 1 second, basically in last 1 second, is going to fill rest half of the beaker. So this is a very cool thing in the sense, like people are going to think like in 59 seconds is going to fill half full, in last 1 second it is going to fill just a little bit. No, this is actually decaying, like growing exponentially, not decaying. This is growing exponentially. So this is what exponential growth looks like. See, okay, have a look at here. So initially exponential growth was very slow, from minus x is equal to minus infinity to 0. So we can write it down like these 59 seconds, this amount of time took from it to grow from x is equal to minus infinity to 0. So this is from minus infinity to 0. After that it shoot up very fast. This is known as exponential growth. Okay, right? So you can search it on internet and you can like look at it. This is very interesting thing. So you can always like have an idea of it. And we'll be doing it in differential equations, like in mathematics you'll do, but before mathematics I'll make you do it. Okay, so this is a very cool thing. And yeah, so is everyone okay with this? So this is an exponential function. This is very important because this will come in physics and nuclear decay. That will not be exponential, that will be exponentially decaying. That's why I'm not writing here exponential decay. But these all things, they are exponentially growing. Okay, right? So yeah, instead of nuclear decay, we can actually write that nuclear fission. Nuclear fission, in fact. Nuclear fission. Nuclear decay is something different. Radioactive decay, that is exponentially decaying, but nuclear fission, it is breaking into few parts, but it is making so many parts in a fraction of time, right? So yeah, these all are the things where exponential curve is used, right? Like which follows exponential stuff. So let's say this is fifth graph, and now let's come to one last one for today. So this is the graph of y is equal to square root of x. Y is equal to square root of x. So this is the graph of y is equal to square root of x. So let's do it. So this is our blue. So this is going to be like this. Is it the angle 0? So this graph is going to, what this graph is going to look like? This is my y, this is my x. So this graph is going to look like this. So basically this graph is always growing, right? So you didn't say anything about nuclear decay. You are a 12th student. Okay, you are a class 12th student. Okay, good. So yeah, this is our graph of y is equals to square root of x. Y is equals to square root of x, and this is going to go from origin. Okay, this is going to begin from origin, and then this will keep on growing. This will always keep on growing. If I look at its domain, let us look at its domain and range, and then we'll end this lecture over here. So let us look at its domain. So what its domain is going to look like? So its domain, we can see, we can only add positive numbers over here, right? We can only add positive numbers over here because we cannot write negative numbers inside the square root, because it will turn into iota, right? It will turn imaginary. So that's why the range, the domain is always going to be positive numbers along with 0. So the domain is going to be 0 till infinity. And what is the range going to look like? What is the range going to look like? The range is going to look like, the range is also going to be exactly same for this function. Fortunately or unfortunately, I don't know what to say, but the range is also going to be the same for this function. It is going to go from 0 till infinity. So this is the domain. Now why is the domain this one? Because we cannot input negative inside. So domain में, so here we can say we cannot wait. So we cannot input negative number inside square root, right? So these are the things which you have to keep in mind. These are the basic things which you have to keep in mind while calculating the domain. Domain, it's very easy to calculate. It's always all real numbers. But those points you have to exclude. Whenever my denominator becomes 0, either my denominator becomes 0 or either we are having some negative number inside square root, right? Is that good? Can't we say the domain will be natural numbers? No, we can't say the domain is natural numbers. What are natural numbers? Natural numbers are 1, 2, 3, 4. Domain is all real numbers minus negative numbers. All real numbers minus negative numbers. You can say R minus all negative numbers, right? So why isn't negative range considered? Like square root of 4 is minus 2 as well. Square root of 4 is not minus 2. My friend Zuhair Mujib, square root of under root of x square is mod x. It is always positive, right? It is never negative. That is a different branch. If you consider y square is equal to something, then it is different. Okay. So is everyone okay with this one? So should we end with this? So yeah, we'll be discussing about decay and log in next class. Yes, absolutely. Decay and log in next class. So yeah, for today, this all wraps up our lecture. So let us have a final look at it. So what did we study today? So the first thing that you have to put efforts. What is the way you have to study? This is the book which you can refer. And these are the details about me. And what is a function? We get an input, we get an output by putting it inside a machine, right? And then we did some graphs. What does a graph of function looks like? Then we did some graphs of some function by equal to x square, 1 upon x, 1 upon mod x, then whatever like e to the power x, very important graph. And after that we ended with square root of x. So this is the final thing which we end up with. So if you are having any doubt, then you can ask in next class. So this class came out to be 1 hour 41 minutes long. So yeah, now I'll take your leave. So yeah, goodbye, namaste everyone, pranam. So we'll meet in the next class. Okay. So I hope you liked it, and we'll crack the exam together, right? Okay. Bye bye everyone. Holy cow, bro. Damn. हाँ जी भाई जी, कौन है लेक्चर वाले? हाँ जी, आ जाओ, मैं बस उसको वो कर देता हूँ। हाँ, अच्छा चल रही थी क्या यूट्यूब पे? हाँ जी, वीडियो बनानी नहीं बनानी है। एक सेकंड रुको, मैं वो करके आया। एक सेकंड, मैं भी बता देता हूँ इनको।